Whoa, whoa. Dunkhaus. We're in the workshop and we've had quite an interesting job come through the door. So I wanted to sort of show you guys this one because it's actually really quite fascinating. So what we got here in front of us is a live axle rear end, a differential. This is out of a Toyota AE86 with a live axle rear end. You get up and down movement, your wheels are square, that's all you get. Heaps of fun, great for drifting, not so good for racing. What you want for racing is a little bit of camber. So can you have a live axle rear end and have camber? Yeah, you can. So this is quite an interesting bit of gear. It allows you to have your live axle rear end here with 2 degrees of camber. And so this is what's called a floating hub. And so it's a floating hub kit that we need to get onto this diff here. How do we do that? Heaps of measuring, heaps of measuring. Because we've got to make sure not only we keep the diff to a desirable width, we don't want this thing stupidly wide so we can no longer put wheels in the guards, but we also make sure that the welding hub here needs to be in exactly the right spot. The problem that we've got is this car is going to be raced in a classic series in tarmac, and so what that means is he's not allowed to change the body mounts on his 4 lengths, so we have to stay unequal 4 length. The issue with unequal 4 length is your diff twists as it rotates through the movement. So it starts like this, and then as it goes up through the movement, your pinion angle changes. Not always a massive deal, but now that we've introduced camber, as the diff is twisting, what actually happens is we twist the diff forward, we induce toe, and even worse, if the diff twists backwards, we actually introduce toe out. So the first one's toe in, sorry. If the diff twists backwards, now with the camber, we're toeing out, which is horrible for a race car because it will make it really twitchy. So we need to make sure we get that in exactly the right sweet spot. So I've also been supplied with this great little setting up tool here, which allows us to measure off of this machine mark. So we've got a lot to work out. The actual part of getting it on there is not too bad. So we're going to cut the diff here, take a few measurements, and we're going to machine this hub down. So they've given us a fairly blank canvas to work with. We've got to get a whole stack of measurements, and we'll machine that to then slide inside the diff, and then that sits in exactly the right spot that we've got to work out. Weld her up, and then bam, you've got 2 degrees of camber on a live axle rear end in your AE86 race car. Wow, that is amazing. Right, so we're not here to put shoes on caterpillars, let's get it done. So this is my personal AE86. We've chucked the diff in here to just triple check over the mount locations, make sure that that's all hunky-dory, absolutely 100%. So far so good. So we had a good look at pinion angles and how all the arms and everything are working at full compression. Just come up on the hoist. We can go to full droop, which is a fair bit on this car. It's going to be running some pretty serious tarmac type suspension. And then at full droop again, just testing and checking everything else. So the main thing I was looking for is the pinion angle on this always stays pointing down. So we're always going to have toe in introduced with the camber kit. That's all good. So we're going to get this back out the car, back on the bench, and we'll look at cutting the ends off. Okay, so we need to work out where we're going to cut this diff so that we can then measure the hubs to get the machine down to then weld them in. Right, so what do we want to find out? So A86 diff width, factory is 1410 millimeters, 1.4 meters. The F series empty housing that we've got is 1315. So I'm going to have to cut them somewhere. We need to work out where. So I just had a bit of a quick look through the instruction manuals that come with the kit, and it says that our minimum amount that we can have for this series of floating hub is 123 mil. The hub of the Camber kit to the weld section, this here to there, is 123. That's my minimum. So I'm going to make it 125 to make things easy. Now we need to work out exactly how much that is. So do some quick maths. I cheat and use a calculator because I'm not smart enough to do it in the head. So 125 times 2 gives us 250. 1410 minus 250 gives us 1160. So that's how wide my two cuts are going to be. So to find out where they need to be, we take this number here, so 1315 minus 1160 gives us 155. If you're doing this quicker than I can punch it into the calculator, I'm sorry, not sorry. And then simple divide by 2 gives us 77.5 mil. So from that point of the diff back 77.5, we chop it. We then machine up our new hub to sit inside here like that. And then when it all bolts back together and we have our camber, that is now 1410. Happy days, let's cut it. So we've got the diff in the bandsaw. Cut up a couple pieces of metal just so we can make sure the diff's perfectly square and retained. The mounts are in a bit of a way, so we had to cut some steel to get it in there. Heaps of measuring, making sure everything's level and set at the same level with the spirit level, and got the dimension exactly right. So that's 77.5. It's probably about 78 to be honest, but that's okay. And we're ready to cut. So we'll have a quick look at the setup. So I've made sure that the setting on my bandsaw here with the level is the same as my diff there. So I was actually having to shim up the back of the diff just to make sure that that level is exactly the same as the base of the bandsaw. So as we cut, it's nice and square to the tube. And then yeah, obviously bits of steel to get around the different brackets. Just double check 77 when we're measuring. Got to measure to the back of the blade, to this face here, to make sure that I'm cutting off that 77.5 mil. So we'll double check that because you always like to cut once and weld 3 times, and we'll go from there. So if you ever wondered how thick the walls of your diff are, pretty beefy, good 5mm wall. I'm just getting the drawing done for the machinist. So we need to machine these down to fit inside the diff. But my lathe's not really gutsy enough for hogging out a whole heap of material and doing quite a large bore. So I'm going to outsource the machining. So need to convey exactly what I want. The best way to do that is with a nice technical drawing. So let's have a quick look at what we're playing with here. So that's what you're looking at there in 2D form with a whole heap of information. So we'll just start with probably the most important piece of information, and that's this outer diameter here. So it's 60.95 with a tolerance plus or minus of 0.02. So when you see that as a machinist, you understand that is a fairly important tolerance and it needs to be hit absolutely spot on. So I want that to slide inside the diff. I don't want it to be a press fit, but I can't have it flopping around either. It just needs to fit exactly in. So we've given ourselves 0.05 clearance for that to work. Like I said before, they give you a heap of meat so that you can have lots of different options on what these get machined down to, and then they suggest in the paperwork that once you figure out what you want, to hog out as much material as possible to make it a bit lighter. Given that, so there's a center line here, and the dotted lines are showing the internal bore at 50 millimeters. So, sorry, back to this top diameter here, that needs to be 52 millimeters long. Now, that step that's created there is going to determine how wide our diff is. So, I've given that a 0.2 millimeter tolerance on that. So, same thing, that's telling the machinist that that's quite an important dimension and he needs to be hitting that exact 52 basically, which shouldn't be a drama. Any machinist can do that, no dramas. And so that's 52 with that important outer diameter, 50 for the internal diameter, and as you can see there, I've left a step here for the internal bore, just to hog out that material to make it a bit lighter. We made that 60 mil, so I haven't put a tolerance on these dimensions because they're not that important. We're just hogging out material to make it lighter, so that 50 mil is not that important, the 60 mil is not that important, hence they don't have tolerances on them. And then the other little thing, I've drawn in some little chamfer points here, and I've made them 2 millimeter chamfers, and then next to it I've put TYP, which stands for typical, which means wherever you see a chamfer on the job, it's going to be 2 mil. So it's just an easy way to draw it rather than having it drawn on every single chamfer. So we'll get that off to the machinist, he'll get them done, and then we can chuck them in the diff and weld them up. So we've got our hubs back from the machinist, did a really nice job. So obviously that was the original diameter that we had. Let's machine it down, bored it out, so they're a whole heap lighter now. I've had a bit of a mess about with them to make sure that they fit in quite nicely, which they do. I've come up with a little bit of a process on how to get these set up exactly right, and we need to do a bit of prep on the diff ready for welding. So it's all coming together. We'll prep the diff, we'll do a bit of measuring to make sure that these things are 100% level when the diff's set square. As per the guys that made these, they were really good. I was actually really impressed with the customer service. They said ring any time, and I did. Rung them a couple of times, had a really good chat with the guys that are designing and making these things, and they were super helpful. So that was really nice to deal with a company with such great customer service and just talk me through every last little step on how to get it done, which was fantastic. So yeah, they suggested set your diff completely square. We've already double checked in the 8.6 that the diff never rotates backwards with the unequal arms, always tilts forwards with the twist, and so we can set these level. So we'll use the bench as a datum, square here, and we'll measure off of this little ground piece of material that I got. So weld prep, tack them in, and we'll go from there. that's all the tricky bit done. All the measurements and making sure that everything's exactly in the right spot. The bit where we got to take our time and take our effort and make sure we get it right is finished. So, had a quick look at the two hubs on the end, make sure it's all looked good. Our width ended up being 14.15, not 14.10, so we snuck a couple of mil in there somewhere, which is okay. And I put my ground bars on here and just made sure that the toe is definitely pointing in, just triple checking. I mean, it should have been right, but it's nice to know. So we're good. That's all everywhere it needs to be, and now we just move on to a whole stack of welding. So we can turn our brains off basically and just weld. Everything's where it needs to be, and away we go. So that's the next step, whole stack of welding. Oh yeah! So what I'm getting up to here is we've done the complete weld around the outside of the hub there, but we're going to have a lot of rotational forces, a lot of rotational vibration, a lot of shock loading as we take off, going over bumps and all that sort of stuff, and over time that can put quite a lot of stress on just a weld around the outside. What you do in cases like this is we actually drill a hole, not all the way through, but we drill into two locations. Now the wall of this diff was 5mm, so I've drilled a hole that's roughly about 8mm deep, so I go into the hub a little bit, and then you fill it up with weld, and you're essentially creating almost like a dowel, like a location dowel out of weld that takes a little bit of rotational force and a little bit of stress off of the outside weld. So yeah, that's what we're getting up to, if you were wondering why I'm all of a sudden drilling holes in what was a completed welded diff. We've got a couple more welds to go. Let's finish her off. There we go, we're all done. So, lots of measuring, a little bit of cutting, making sure the bits that were right were right. A little bit of welding to finish it off. So if you want camber on your live axle rear end, it's as easy as that. Just cut the ends off, weld some bits on the other end. Piece of cake. Oh, all seriousness, it's a pretty interesting job and a really nice bit of kit. It bolts to the end there. It's quite fascinating the way it works. So yeah, that was enjoyable. Now that we've cut that to length, obviously it's up to us exactly how long we want it. A few measurements will be made to go back to the company, and they make axles custom for the length that you ended up making the diff. So there's a few measurements to go, but as far as Tommy Dunkhaus and the Second Stage workshop, our work is done, so they'll get picked up and hopefully get in the car and get it rolling real soon. So thanks for watching, guys. I had fun on that interesting project. Hope you guys enjoyed watching along. Take it easy.